Now that we've worked with triangles for a little bit, let's go ahead and start looking at how we're going to define trigonometric functions. Well, to get started with trigonometric functions, the first thing we need to do is we need to recall the Pythagorean theorem. Now, the Pythagorean theorem, if you'll recall, only applies to right triangles. So in this particular case, we'll draw a right triangle and we'll label everything. And again, the way we show that it's a right triangle is a little square in the corner. This is called a leg, and this is also called a leg, because these are the two sides that make up the right triangle, or the right angle here. The side across from the right angle is called the hypotenuse. So what the Pythagorean theorem says is that if I take one leg length and square it, and I add it to the other leg length and square it, I will always get the hypotenuse squared. So that's the Pythagorean theorem. Now, a lot of times what ends up happening is these legs end up being labeled A and B, and the hypotenuse is labeled C. And so this breaks down then to A squared plus B squared equals C squared. But remember, it's really leg squared plus leg squared equals hypotenuse squared. And remember, this is only true for right triangles. Now, along with the Pythagorean theorem, we also need to recall the distance formula. So let's look at the distance formula. Now, this is basically talking about the distance between 2 points, and in this particular case, we'll say the distance between 2 points P and R. So the distance between point P, and we'll call this x1, y1, are the x and y coordinates, and R, and the coordinates for R would be x2 and y2. Then the distance formula D, and this particular textbook denotes this P comma R, so this means the distance between P and R is equal to the square root of the difference in the x's, and it doesn't matter which order we go here with the difference in the x's, squared, plus the difference in the y's, squared. Okay, so that's the distance formula. Now, the distance formula can be derived from using the triangles and also looking a little bit at the Pythagorean theorem. If you want to look at the definition of that or how that's derived, let me know and I'd be happy to write up a short video for you. It's also in the e-text in my math lab. Now, one other thing we need to review is the Cartesian coordinate system. With the Cartesian coordinate system, we've already looked at this, but we're going to specifically look at the x and the y values in each quadrant right now. And we want to know whether they're positive or negative, because it matters where we're at in the Cartesian coordinate system. So let's go ahead and label these quadrants. So this is Q1, we use Roman numerals, Q2, Q3, and Q4. We run counterclockwise. Now in Q1, remember, my x value is always first and my y value is always second when I talk about an ordered pair. If I was going to graph a point, here the x value is always positive and the y value is also always positive. In the second coordinate, or the second quadrant, again x, y, the x value is negative, the y value is positive. Remember, it goes in the order of x, y. In quadrant 3, they're both negative. And then in quadrant 4, the x, y is positive and then negative. Now this will end up being important, so we always know kind of where our location is of the angles we draw, and we'll want to know exactly where we're at based on the x and the y value that we're going to be talking about. So knowing these values for your Cartesian coordinate system is important. You probably already know them from graphing points, but it's also a very good idea to review them and have them at hand right when you need them. So to start defining our trig functions, we need to think about drawing an angle, because our trig functions are always based on angles. So let's look at defining the trig functions. Now these angles can be drawn anywhere in any quadrant. The example I'm going to show right now is just talking about an angle that moves into the second quadrant. So I'm just going to draw the top half of the Cartesian coordinate system. So from looking at this, what we're going to do is we're going to have some point P, and again the point P is given by an x and a y value, and I'm going to talk about this point P that's on the terminal side of an angle and we're going to call that angle theta. Okay, so here's our initial side. So again, our initial side always starts here. The vertex of this angle is right here at the origin. I'm going to call this point O. And then I have this other point P that lies on the terminal side. So here's my terminal side somewhere over here. So again, this is initial. This is my terminal side. Now, I can use this for any point on the terminal side, so it doesn't have to be just this specific point P. It could also be down here. I could define another point and another point, but I want to use the point P for this particular case. Can't get rid of that point. So this is point P, and again, it's defined by x and y. Now what we want to do is we want to look at the distance from the origin, or this point O, to this point P. Now there's one thing about P that we have to be careful of. It can't be the origin. It has to be away from the origin. It has to be a point away from the origin, not on the origin. So in this picture, when I draw this out, if I drop an altitude to the x-axis, it creates a right angle, and then the length of this from P to the x-axis is a length of y. And the length of this from the origin to where the altitude dropped would be this value of x. And this is the angle that's produced, is angle theta. So you can see we have a right triangle here, and of course as soon as we have a right triangle we can start thinking about things like Pythagorean's theorem. We can also talk about some other things defining some trig functions as well. Now this distance, we have y and x, this distance between the origin and this point P we're going to call r. And eventually this will be the radius. We'll start talking about a circle drawn around from this center at the origin, but for now we're just going to call it r. Now to find the length of r, we just use the distance formula. So r would be the square root of the difference in the x's, which would be x minus 0 quantity squared, plus the difference in the y's quantity squared. So if we simplify this, we get r is equal to the square root of x squared plus y squared. This is important to remember. Okay? And if it's not a formula you have to memorize because you know Pythagorean's theorem, so you should be able to come up with it anyway. Now, we don't have to worry about plus or minus here because I'm only talking about the positive distance from this point O to this point P. Okay? And again, we're going from initial to the terminal side for that. Now once I have this set up, I can actually write out all my trig functions. So my trig functions are defined, and again this is my angle theta, and I'm kind of stickler about this. In my math lab, a lot of times they just write sine theta without the parentheses around the argument of the trig function. And what's going to happen eventually is we're going to be talking about things like theta plus 2. And then it becomes the question, is the plus 2 go with the theta or not? So does this mean sine of theta and then plus 2, or the sine of the argument theta plus 2? And so just to clarify that, I always put parentheses around the argument of every trig function, and this will be something I'm looking for on your exams when you're showing your work, and you'll also see this in my handwritten homework. And again, my math lab does not use this. Sometimes they'll throw it in some problems, but they're not consistent with it. But I expect you to be using parentheses around the arguments of your trig function to clarify exactly what the argument is. So let's go ahead and define these. Sine of theta is equal to the y coordinate divided by this value of r, which is we can call the radius. Now we also can talk about cosine of theta. This is equal to x over r, and tangent theta. Tangent theta is y over x. Now in this particular case, we need to also say x cannot be equal to 0. And that would of course put us right at the origin, and we know that this can't happen excuse me, because the point P cannot be on the origin. Here we don't have to worry about r being equal to 0 because the distance r has to be at least greater than 0 because it's not exactly on the origin. Okay, so this is sine, cosine, and tangent. They don't bring this up right away, but I'd also like to talk about cosecant, secant, and cotangent as being the reciprocals. So let's look at cosecant. Cosecant is r over y. Secant is r over x. And then our last trig function is cotangent of theta, which is x over y. Now a couple things here. Y cannot equal 0. I can't be at the origin. That's what that's saying. X cannot equal 0. And again, y cannot equal 0. Now there's a couple things I'd like you to note here that has always made these easy for me to memorize these as trig functions. The y over r and the r over y, they flip. So cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. Now you'd think cosecant and cosine would go together, but they don't. So that's how I remember which ones are reciprocals. I think, oh, sine will go with the one that is not what I would expect it to be. It goes with the cosecant. So remembering that these are reciprocals is very, very helpful. Let's make those notes. These are reciprocals, meaning I flip them. Now, when you use your calculator, most of your calculators only have sine, cosine, and tangent on them. But if you remember the fact that they're reciprocals, I can also find cosecant, secant, and cotangent using the calculators as well. So what I'd like to do with this information is to go ahead and run through a few problems. So I'm going to pop in some problems that you'll see in my math lab, and that way we'll be able to work through those problems that are specific to your problem set in your homework. Okay, so this would be similar to one of the beginning problems that you'll see in your homework. So as we're working through this problem, it says sketch an angle theta in standard position such that theta has the least possible positive measure, meaning we only go around the Cartesian coordinate system or the circle a minimum number of times, so that the point 512 is on the terminal side of theta. Well, 512 is kind of their important thing here. This means I go over 5 units on the x and up 12 units on the y, so that definitely puts us in this first quadrant. So this is the correct graph of that. Now notice our scale here. These look like 3, 6, 9. These look like tick marks of 3. So this is 5 is going to be slightly over here. So don't think about moving over 5 tick marks. Just be careful about what they use for scale there. And then it says, then find the exact values of the 6 trig functions for theta. Well, what I'm going to do is I'm going to blow this triangle up just a little bit. It's in the first quadrant. So I'm going to look at this in the first quadrant. This is my angle theta, and this is my ordered pair 512 at this point. Okay, so this is 5. Sorry, this is 12, and this is 5. So this length is 5, this height is 12. So now I need to figure out what r is. R is the square root of x squared plus y squared. So this would be the square root of 25 plus 144, which is the square root of 169, which is 13. So r is equal to 13 here. Now when I set up my trig functions, you can start with any of them that you want, but it's pretty common to start with sine or cosine first. So the sine of theta, and again please put parentheses around the arguments of your trig functions. Sine is equal to y over r. Y in this case is 12. So this would be 12 over r, which is 13. Now if I can reduce this, I should, but this is not reducible, so I leave it as is. The cosine of theta is equal to x over r. X in this case is 5, so 5 over 13. Tangent theta is equal to y over x. So that's going to be equal to 12 over 5. So these are the 3 basic trig functions. Now let's go ahead and look at the reciprocals. So the reciprocal of sine is cosecant. So that's going to be r over y. So in this case r is 13 and y is 12. So again, it's just the reciprocal of the 12 over 13 that we see here. Okay, the reciprocal of cosine is secant. Secant of theta, and again, please put parentheses around the arguments of your trig function. This is r over x, so that would be 13 over 5. And our last one here will be cotangent, and that's the reciprocal of tangent. So the cotangent of theta would be x over y, which would be 5 over 12. So now I found these ratios of my trig functions. Now we're not doing much with these right now. What we're doing with them right now is just learning how to find them. Now some of you may be familiar with Sohcahtoa. So I want to talk about Sohcahtoa real quick. The textbook that we have is based on unit circle trig. There's kind of two approaches that we can take to trigonometry. There's unit circle trig and there's right triangle trig. They all get us to the same answers. It's just a different way of explaining it and a different approach. Well, those of you who are familiar with Sohcahtoa or have seen this before, you're welcome to use it. The way we're developing this, you can see where it's going to jump in, but you'll see in some quadrants it doesn't quite work. So Sohcahtoa in this particular case, and if you don't want to learn Sohcahtoa, you can just fast forward through this. This means the sine is equal to the opposite over the hypotenuse. So SOH, sine opposite over hypotenuse. Then it talks about cosine of theta being the adjacent leg over the hypotenuse, and then tangent of theta being opposite over adjacent. Okay, and we'll talk about the right triangle part of this when we get a little bit further on in the class, but I know that some of you are already aware of it, so I wanted to point it out real quick. So for this particular case, when we talk about the opposite leg, we mean the leg opposite the angle that we're looking at. So opposite to theta would be 12. So this would be 12 over the hypotenuse. Now remember, the hypotenuse is the side that is opposite the right angle, and in this case the hypotenuse was equal to our value of r, which is 13. So you can see we get sine of theta is 12/13, the exact same way that we do here. And for cosine of theta, that would be our leg that's adjacent. So here's opposite. Here's our leg that's adjacent. So this would be adjacent over hypotenuse, or 5 over 13. And you can see that that matches here. And then opposite over adjacent would be 12 over 5 for tangent. So if you're used to working with right triangle trig and you'd prefer to do that, that's fine. Just as long as you always show your work, because I always want to see your work and how you get your answers. Okay, so let's go ahead and look at a few more examples. The next one I want to look at, we're talking about the quadrants that we're working in, and within these quadrants we want to make sure that we can look at whether we're looking at a quadrantal angle and finding those values for sine, cosine, tangent as well. So for this example, we're going to be looking at the point 0, -2. So 0, -2, that's kind of our important point here. Now remember, this is the x value and then the y value. So I start at the origin and I move 0 points in the x direction. So I move 0 left or right. Then I move 2 down in the y direction, and so that would be this graph of B. Okay, so that's the point that we're looking at here. Now there's a couple things now that we have to find our trig function. Let's go ahead and blow this up again. This one's not quite as interesting as our last one. Here's my initial side, here's my terminal side, here's the rotation, here's theta, and I'm going to use the point 0, -2. So now when I find my value of r, I really don't see a triangle to draw here because I can't drop in altitude because this point is the dropped altitude from the origin. But I can still find my value for r. So r in this case would be the square root of x squared plus y squared. And you'll kind of see something interesting happen here. So 0 squared plus a -2 squared. Now this would be r is equal to the square root of 4, which is 2. So r would be equal to 2. Okay, so now a couple quick things. -2 squared and -2 quantity squared are two different things. This means to take a negative sign and then take 2 and square it. This means to take a -2 because it's in the parentheses for my base, and multiply it by itself. This is -4, this is +4. So if you write this out as 0 squared plus a -2 squared, that's incorrect, and we'd get the square root of a -4, which would be a 2i, which is a complex number. So make sure that when you write this, you have your parentheses around the base, just to clarify everything there. Okay, so now what are we looking at here? We want to start with sine. So sine of theta is y over r. Remember, this is our x and our y value. So in this case, y is -2. R, in this case, is 2 from up here. So we get -1. Cosine of theta is equal to x over r, which is going to be 0 over 2, which is 0. Tangent theta is going to be y over x, which is y is -2 over x, which is 0. This is strange. Anything divided by 0 is undefined. It's not 0, it's undefined. And I'm going to put that in red because I want to make sure we remember that one. So -2 over 0 is undefined. Now if you're checking any of these answers on your calculator, you know, if you were to put -2 over 2, hopefully you wouldn't have to check that on your calculator to get a -1, but if you are, sometimes it'll just say error. It won't say undefined, so make sure you understand anything divided by 0 is undefined. The reciprocal of secant is cosecant. Okay, and this is r over y, which is 2 over -2, which is -1. Secant of theta is r over x, which is 2 over 0. And again, anything divided by 0 is undefined. So these trig functions are not defined for this coordinate. Now our last one here is cotangent. So the cotangent of theta is x over y. So now we have 0 over -2, which is 0. So some of these, 2 of these in this particular case did turn out to be undefined, and you would expect to see that on any quadrantal angle. So for any quadrantal angle, you'll see some things, some of your trig functions show up to be as undefined. Okay, I want to do one more of these, and again, if you have this down and you feel like you don't need to see another example, go ahead and fast forward through it. Okay, so for this one, we don't have an integer value for our ordered pair. We have the point -2 square root of 2. So remember, this is our x value and our y value. So I'm going to go over negative and up positive. So that's going to put us right here. Now if we had 2 points that were in here, it would be hard to determine exactly what was going on. But root 2 is somewhere between 1 and 2. It's about 1.414. So this is our value right here on our y-axis. Now because this is a little bit hard to work with in its current small form, I'm going to go ahead and blow this graph up and just kind of take a look at that second quadrant. So again, our point was -2 square root of 2. And this is our initial side, this is our terminal side, this is our value for theta, and I'm going to call it this point right here. So -2 square root of 2. So this height is square root of 2. When I drop my altitude, this is square root of 2. This length is -2. And now I want to find my value for r. Okay, so remember r is going to be equal to the square root of x squared plus y squared. So -2, and remember that -2 has to be in parentheses, because if you don't, then it should be a -4, and it has to be a +4. So that's -2 times -2 is 4. Root 2 times root 2 is 2. So this is going to be the square root of 6. So r is the square root of 6. Here's my right triangle marking, and then I can find all my 6 trig functions from here. So the sine of theta, again, is y over r. In this case, let's put down our ordered pair right here. xy was negative 2 root 2. So my y value is root 2, and my r value was root 6. Now we usually don't leave a radical in the denominator. We usually rationalize this. So I'm going to multiply top and bottom by the radical. So I'll have root 2 root 6 over root 6 times root 6 is the square root of 36, and the square root of 36 is 6. So you just get the radicand back. So root 2 times root 6 is root 12 over 6. Now we can do more to simplify this. Now you're probably familiar with simplifying radicals. If you look at root 12, there's a factor of 12 that's a perfect square. That would be root 4 root 3 over 6. This would be 2 root 3 over 6, and of course the 2 cancels into the 6 3 times. So I am left with finally that the sine of theta is equal to the square root of 3 over 3. Okay? Now right away from here I'm just going to look at our reciprocal. The reciprocal of sine is cosecant. So the cosecant of theta is going to be, I'm going to flip that, it's going to be 3 over root 3. I rationalize again, and I'm going to get 3 root 3 over 3, which cancels, so I'm left with root 3. Let's go ahead and look at the cosine of theta. Cosine of theta is x over r. X in this case was a negative 2, so I'm going to bring that sign with it. R was a was a root 6. I rationalize the denominator, and I get negative 2 root 6 over 6. I have some canceling that can occur here, and I end up with negative root 6 over 3. And then of course, because I know that my reciprocal of cosine is secant, the secant of theta will be that reciprocal. So that'll be a negative 3 over root 6. And it doesn't matter where the negative goes, top or bottom. Okay, usually you put it up front or up top. Usually don't put it in the bottom. And then I'd rationalize, and I'd be left with negative 3 root 6 over 6. I have some canceling that will occur here, and I'm left with negative root 6 over 2. I still don't know what this angle is, but I know all there is to know about the trig functions. Now the last one that we can look at, let's look at tangent. Kind of running out of room here. Tangent of theta is y over x. So for y over x, this would be the square root of 2 over a negative 2, but I'm going to pop that 2 out front, so that way we can keep track of it. We usually don't leave the negative signs in the denominator. And then cotangent of theta would be the reciprocal of that. So it would be a negative 2 over root 2, negative 2 root 2 over 2, some canceling occurs, and I'm left with negative root 2. So radicals don't change anything, even though these values, this y value wasn't a nice little integer. I can still work this problem. It's the same approach that we take to all of them. Once you find your correct graph here, it's probably pretty helpful to blow up that graph a little bit like we did over here, to make things a little bit easier to work with. Okay, let's go ahead and look at another example. I want to make sure I do plenty of examples for you, so that way when you get to your homework, you have a lot of reference material to look at. In an online class, it's a little bit harder because you're on your own a lot of times, so I always want to make sure that you have all the information that you need. And again, if you don't need to watch these, that's okay. You can skip through the ones you need to watch, and you can kind of ignore the other ones if you need to. So for this next problem, it says, suppose that the point xy is in the indicated quadrant. Decide whether the given ratio is positive or negative. Okay, so this one's going to be pretty straightforward. We're in quadrant 2. So that means I'm somewhere over here. I'm going to go ahead and draw this. It doesn't say where I am, I just know I'm in quadrant 2. Well, if I look at quadrant 2, whatever point this is going to be a negative x and a positive y. Because in quadrant 2 the x value is negative, and the way that we say that is we say x is less than 0 and the y value is positive, so y is greater than 0. So if I look at this ratio y over x, then we just said that y was positive and x was negative, and it's not necessarily -1, it's just negative. So that tells me that this overall ratio is negative. Okay, so I just need to draw the quadrant I'm in, and then once I know the quadrant I'm in, I can go ahead and pretty easily discern what that ratio will be. Let's look at another one similar to that problem. This one, we're going to be in quadrant 3. So in quadrant 3, and let's go ahead and draw that terminal side in quadrant 3. And again, I don't know where it is in quadrant 3, I just know it's in quadrant 3. Here's some point xy. Well, remember in quadrant 3, this point xy, x is negative and y is negative. So what we would say here, that in quadrant 3, x is less than 0 and y is less than 0. They're both negative. So if we look at the ratio x over y, and we already know r is positive, if we look at the ratio x over y, that's going to be a negative over a negative, which is a positive. So this particular ratio, x over y, is going to be positive. So x over y is greater than 0. So again, those are pretty easy to work through. Just make sure you identify the correct quadrant. There's quite a few of the problems that you're going to be working through in my math lab that are similar to this, but I think this gives you a pretty good idea of what to expect for those problems. Now we have another type of problem that you're going to have, and that is instead of being given a particular point, you're going to be given an entire line to be looking at. So again, instead of just a single point, you'll be given an entire line. So let's look at an example where that would be given. And we're going to find the trig ratios as well. So we're going to try and sketch this out and find the trig ratios. So instead of being given a point P on the terminal side, we're given an entire equation that describes the terminal side. So here the equation that we're given is 5x plus y equals 0. Well, 5x plus y equals 0 is basically made up of an infinite number of points. So how do I figure out what's going on here? Well, what we'll do first is we could sketch this line. We have a restriction here. My x values have to be 0 or less, 0 or negative values. And then we can work from there to figure out what's going on. So let's look at 5x plus y equals 0. Well, this is, if I solve for y, I get y equal negative 5x. This is in the y equal mx plus b form. Now remember, m is slope, and b is your y-intercept, where it crosses the y-axis. So for our case, y equal negative 5x, I could look at that as negative 5x plus 0. So here our slope is negative 5, and our y-intercept is equal to 0 then. Okay, so we have a negative sloping line. We have our y-intercept is equal to 0, so I know it's crossing through the origin. So let's go ahead and try and graph this out. I'm not sure what quadrant this is going to put me in right away, so I'm going to go ahead and put up all 4 quadrants of the Cartesian coordinate system. So again, my y-intercept is 0, so that means I'm crossing here. Now my slope is negative. It's a negative 5. So negative 5 over 1. Remember, slope is rise over run. So from this point, I am going to choose to rise 5 and run a negative 1. If I wanted to, I could drop 5 and run a positive 1, but I'll show you why I chose this instead here in a second. So I'm going to go 1, 2, 3, 4, 5, and then I'm going to run a negative 1. So this would be my next point right here. Now the reason I did this is, remember our restriction back up here. It says x is less than or equal to 0. So in order for x to be less than or equal to 0, that would mean that I'm to the left of the origin. So that's why I chose to move in this direction. So this is the terminal line. And so this is my angle theta. Now this line goes on forever in this direction as well, but remember we're only interested where x is less than or equal to 0, so that's why I'm just looking at this half of the line. So I would drop an altitude, put in my right angle. Okay, now if I want to figure out what happened here, remember this is the point P, this is -1, 5. So this height is 5, -1 is this horizontal distance, and I need to find r. Well, our formula for r is based on Pythagorean's theorem. That's the square root of x squared plus y squared. So x was -1, that needs to be in parentheses before I square it, plus 5 squared. So that's going to be the square root of 26. So this is r equals the square root of 26. And that's just finding the hypotenuse basically using Pythagorean's theorem. Well, let's go ahead and set up our trig functions here. So let's do sine first. So sine of theta is y over r. Y in this case was 5, because again this is my x and my y value. 5 over the square root of 26. And again we always rationalize the denominator. So this is going to be 5 square roots of 26 over 26. Well, I can also find the reciprocal of sine, which is cosecant. And I can go back to cosecant and I can find that from here, or I could go back to the reciprocal from here. And that would be the square root of 26 over 5. And the reason I want to go back is if I flipped it from here, I'd have to rationalize again. And I don't want to do that. So let's go ahead and look at cosine next. Cosine of theta is x over r. X is -1 over the square root of 26. Rationalize that denominator. This is negative square root of 26 over 26 then. The reciprocal of cosine is secant. The secant of theta I'm going to find from right here. So that would be a negative root 26 over 1, or just negative root 26. Okay, last one to find is tangent and cotangent. Tangent of theta is going to be y over x, and that's going to be 5 over -1, which is just -5. The reciprocal of tangent is cotangent, and that's -1 over 5. I'm just going to reciprocate from here. So this is an example of using an entire equation to find that. Now another approach that we could have taken here is to find a point just by plugging in. You can use any point on this line. You could use this point, this point, this point, and we're going to get the same answers because it's all about the angle. It's not about the exact point on the terminal side. It's about this where it ends on the terminal side, but not which point that I want to look at on the terminal side. So another way I could have done this same problem is I could have taken my line 5x plus y equals 0, and I could have just decided to choose a value for x and see what I got for y. So I could have said, okay, let's let x equal, I can't say 0 because then that would put me at the origin. I could say let's let x equal -1. And again, I have a restriction here, so I need to make sure I choose x's in that restriction. And then for my y value, I'd plug a -1 in. -1 times -5 is 5. And I could find the point that way as well. I could have used -2. If I plugged a -2 in, I would have gotten 10. All my ratios would have been the same after they were reduced. So again, this is an example of another way to approach this same problem. Okay, to finish up, let's go ahead and look at some problems where we're looking at quadrantal angles. So I want to look at the 0 degrees, and I want to find all the trig functions for 0 degrees. Well, if we look at this in terms of a sketch, we'll see that 0 degrees, the initial and the terminal side are the same because I don't rotate at all. So here's my initial in the blue, and here's my terminal in the red, and here I am at 0 degrees. So when I'm trying to find the values for my trig functions, I need an x and a y and an r, and it doesn't look like I have any of that here. So what we want to do is just pick some point on here. It could be any point. Well, I'm going to choose this as being the point 2 on the horizontal and up 0 on the y. So this is my x and my y value. I could have picked 3, 0. I could have picked 10, 0 or 1,000, 0. It has to be any point on this terminal side. So then I find my value of r. r is equal to 2 squared plus 0 squared. Square root of 4 is 2. So r is equal to 2. And then I can find all my trig functions from there. So sine of theta is x over r. And in this case, x is 2, so 2 over 2. I'm sorry, sine of theta is y over r. Getting ahead of myself. Sine of theta is y over r, so it'd be 0 over 2, which is 0. And of course, from there, I know that the reciprocal of sine is cosecant of theta would be 2 over 0 then, which is undefined. I could find cosine of theta, which is the x over r, and that would be 2 over 2, which is 1. And then from there, I can also find the secant of theta, the reciprocal of cosine. The reciprocal of 2 over 2 is 2 over 2, which is 1. And I can also find tangent. So the tangent of theta is y over x. And in this particular case, y is 0. 0 over 2 is 0. And the reciprocal of tangent is cotangent. So the cotangent of theta is x over y, or the reciprocal of tangent would be 2 over 0 is undefined. So whenever you're working with these quadrantal angles, like 0, 90, 180, 270, 360, or any multiples of them, what ends up happening is that you are going to get some of your trig values to be undefined. So this is an example where we can combine some information about these quadrantal angles. And again, I think the book encourages you to memorize the trig functions for the quadrantals, but really you can come up with them if you need to. And of course we have calculators too, but we want to make sure we know how these are derived. So let's look at 2 tangent 180, and again, they should be putting parentheses around the arguments of their trig functions. Drives me crazy. So here we have 2 tangent 180 plus 4 secant of 0. Well, we just were working with 0 up here, so let's go ahead and run up here and find our secant of 0. I guess we could have put in 0 degrees for each of these thetas, but here's the secant of 0 is 1. Okay, now the tangent of 80. So let's look at the tangent of 180. So 180 is right here. So here is our initial side. Here's our terminal side. And I choose any point on this, and just to make things easy, I'm going to choose -1, 0. And so r would be the square root of -1 squared plus 0 squared, which is the square root of 1, which is 1. So r would equal 1 in this case, which actually I guess we didn't need because tangent is equal to y over x. And so y in this case is 0 over -1, which is just 0. So this would be 2 times 0 is 0, 4 times 1 is 4, 0 plus 4 is 4. Okay, now there's one other type of problem that you'll see that I just want you to see an example of so you're a little bit familiar with it. These are looking at multiples of trig functions. So these are a little bit different. So let me grab one of those. Okay, and again, it's looking at a multiple here. Okay, so what this 4n plus 1 means, if we think about plugging in values for n, if I plug in, let's say n equals 0, n equal 1, n equal 2, n equal 3, and so on, I'd have 4 times 0 plus 1, 4 times 1 plus 1, 4 times 2 plus 1, 4 times 3 plus 1. So if I look at these, I would get 1 for my first one, 5, 9, 13. So you can see these are increasing by 4s, but these are all odd. So that 4n plus 1 says odd multiples. We're looking at cosecant, and we're looking at odd multiples of 90 degrees. So let's go ahead and sketch that out and see what that looks like. Here's 90 degrees. Okay, so here's our 90 degree. So here's a 90. If I just went with, let's say, 3 times 90, that would put me at 270. That doesn't bring me back to this same spot. So we want to look at odd multiples of that. So that's going to be a little bit different. So if we look at the multiples, this is saying 1 multiple of 90, 5 multiples of 90, 9 multiples of 90, and 13 multiples of 90. Well, 1 multiple of 90 puts me right at 90. Now if we do 5 multiples of 90, that would be 1, 2, 3, 4, 5. That still puts me right at that 90-degree angle, but with more rotation, but it leaves me on the same terminal side. Now the same thing will happen with 9 and with 13 as well. So if I talk about the cosecant of this, 4n plus 1 times 90 degrees, that's really just the cosecant of 90 degrees. Okay, because every time I go through this rotation, I'm still hitting that same terminal side. Now remember, cosecant is 1 over the sine of 90 degrees. Okay, and the sine of 90 degrees is y over r. So the reciprocal of y over r, because when you divide by a fraction, you multiply by the reciprocal, would be r over y. So let's go ahead and just choose a point on here. I'm going to call this an exaggerated point of 0, 1, just because they're smaller numbers, easier to work with. So my y value here is 1, and my r value then would be the square root of x squared plus y squared. 0 squared plus 1 squared. Square root of 1 is 1. So 1 over 1 is 1. So the cosecant of 90 degrees is 1. Now again, on your calculators, if you're using calculators for any of these, please make sure you're in degree mode. One of the most common mistakes is to be in radian mode, and we haven't even talked about radians yet. So if you're using a calculator, make sure you're in degree mode. Okay, so I know these videos are long, but they're very detailed and they give you a lot of information. Again, the feedback that I get from previous online classes is that we want more information, not less. We can fast forward through what we don't need, but find extra if we do need it. So if you have questions, please take a screenshot. You're welcome to text me anytime with any questions that you have, and I'll always get back to you as soon as possible. Good luck, and please let me know what I can do to help.